Hey you guys, welcome back to the channel PhysicsSirjee, and here we are in a new video in which I'll be solving a question from Jaan Kalda's problem sheets on electricity and magnetism. And it's a nice little trick that generally students don't study from their usual coaching materials or textbooks. It's a problem which could be modified and asked in a future JEE advanced examination. So along with that, during this particular video, at the end, I would be providing you with the Jan Kaldasar's formula sheet for JEE advanced. Actually, that sheet was intended for a IPHO formula sheet. So what I have done in that is, in that formula sheet of just 4 pages, I've ticked the ones which are important for our JEE advanced. It gives us a very quick revision during the last leg of your preparation for JEE advanced, especially with the advance only 2 or 3 months away. Okay, so let's try to see. So it's a double bonanza. You'll be learning a problem solving method that is less seen in our textbooks. Along with that, you'll be seeing some practice problems, as is the case with most videos in our channel. At the end, I'll be giving you practice problems and also the marked problems formula sheet for JEE Advanced. Okay, so let's go ahead. So these are the three things in sequence in our video we are going to look at: negative resistance problem method, and then SIR's formula sheet, which I marked for JEE. So they will be containing a lot of other stuff which are not there for JEE. So I'll try to tell you how to utilize it and also how to download it. Okay, so let's go with the problem first. There is an infinite triangular lattice. The edges of the lattice are made of uniform wire. The resistance of each edge is capital R. Let us denote the corners of the triangular lattice faced by ABC, as he's saying. The wires connecting B and C is cut off. Determine the resistance between A and B. Okay, so there is an infinite grid kind of a structure. Each of these edges are resistance R, and he has removed one of those resistors. Okay, and he's taking the resistance across the other side. Okay, A and B, which is slightly off symmetry, right? This is not a symmetric problem that you cannot directly solve. Okay, so let's try to see what is the hint, because there's no solution for this particular problem in the SIR's sheet. So let's talk about Carla Sir's handout, okay, of electricity and magnetism. It's electric circuits handout, in which idea number 23 refers to the current problem. So sometimes the problem symmetry it can be achieved by introducing fictitious negative resistances. Fictitious means imaginary. Okay, so there is no problem with applying Kirchhoff's laws to negative resistances, because it's just a term that you are adding and subtracting. In particular, what he tries to say is that the resistance capital R and small minus capital R in parallel corresponds to an infinite resistance. So that means if you're having a gap between two terminals, then that gap can be filled by a resistance R and a minus R in parallel, which leads to not changing the circuit. And in series, it's obvious that capital R and minus capital R can be added in series. Okay, so these are the two ways of making sure if a symmetry is missing in a infinite grid circuit or any circuit, we can plug that one. Okay, so I'm going to utilize that in our problem. So step one of solving the problem is a triangular lattice grid of infinite structure with all resistances present. This is a standard problem that any JEE advanced aspirant actually studies, but I am assuming that you are a student who are doing this from the basics. So let me give you a quick reminder of how that method goes. Okay, so I'm telling you what we are going to do on this slide is finding out the resistance with all resistors present, okay, between A and B. So maybe C is here on the screen here. So this BC resistor will be removed in our next slide. So what we do here is to pump current. Imagine I take the A's terminal and zoom it here and think I'm going to pump a current I into it. Okay, this is one problem. I'm not going to extract the current from B in this problem. So only pump current, since this is an infinite grid, all 6 directions that you can see around A will be equivalent, and current I by 6 will start moving out from this point A. Now, in another problem, completely different problem, at B, you will going to only extract current. Okay, so what happens is, since all the 6 resistors are identical with this lattice being infinite, remember this picture is showing as finite resistors, but imagine this is extending in all directions to infinity, then all these 6 directions lines will be equivalent. Therefore, the current I by 6 will start going towards this B terminal in an equivalent manner. What we have in our usual problem when we find resistor is to connect a battery between A and B. When you find equivalent resistance, you want to connect a battery. And what does a battery do? Simultaneously, it will pump in a current at this terminal and extract the same current from the other terminal, which is nothing but superposing these two events. So in this left side event, there was I by 6 flowing like this from A, which superposes here. And in this right side event, there is an I by 6 flowing this way, which is going towards B. Okay. So when you merge these two at this AB segment, the total current flowing towards right by superposition principle is going to be I by 6 to plus I by 6. Can you see that? Now we are going to add these two. So what does that effectively mean? That if I had a battery which is giving in a current of I to this terminal and extracting a current I from this terminal, as an effect, whatever happens in the rest of the circuit, we definitely know I by 6 plus I by 6, which is I by 3, flows in this direction. So this is a basic thing that you should be able to recognize. And then we apply Ohm's law along the direct path AB. So from A to B, if I were to write Ohm's law, you would be saying VA minus I by 3 current flowing into resistance R equal to VB. Now what we'll do is we'll rearrange this to write it as an effective resistance between A and B. So how do you calculate the resistance effectively between 2 points? You take the potential drop across the 2 points, this blue terms, and divide it with the current that you have pumped at one place and extracted at another place. When rearranging this term in this manner, you'll end up getting it as R by 3, which is nothing but the definition of R effect. Now, step 1 is done, and we all believe that with all resistors present, the resistance effectively between two adjacent nodes is R by 3. Taking this calculation, let's move into the next slide. Now, what we are going to say is this R by 3 can be represented in two manners. One, this infinite resistor grid where you could see all resistors are R and this is capital R. You could say that this infinite grid, see whatever this diagram is, I am trying to depict it in this pattern. Okay. So A, B, and C with all the branches going up till infinity. I would say this is equivalent to a finite resistor circuit with two terminals A and B. And between A and B, if the resistance effectively is X, right, that means I'm replacing all these infinite branches with a single terminal resistance of X. Okay, right. And then there is another single resistor connecting between A and C called X, and the third one between B and C called X. You can question me saying, how can you say this is X and this is also X? Remember this symmetry in all three directions. That means in any direction, if I travel, if I'll get the same type of circuit, therefore the effectiveness of reducing each branch to the same X is correct. Now, what should be the value of this X so that my previous slide answer of this R by 3 is correct? So between A and B, because I already know the answer for the effective resistance, the value of that X can be calculated like this. Okay. So for RAB between this X and X are in series, which is a 2X, and 2X in parallel with X is a 2X by 3. So that 2X by 3 should be equivalent to R by 3, which means each of these X is nothing but R by 2. So if I were to have, listen carefully, if I were to have all resistors intact, then this infinite grid which is on all three directions of ABC. Remember, if this is ABC, all three directions you have infinite grid of resistors can be reduced effectively to a single triangle of X resistance each, where X is given by R by 2. This is the step 2. Now we will transfer this understanding into our actual question where the resistance between B and C is missing. Okay, so I have drawn that original picture from Kalda sir's circuit diagram where B and C, now the resistor is missing. Now I'll use his technique of making sure whatever missing symmetry is, I'll add it back. So what he says, if an infinite resistor is between B and C, that is, it's an open circuit, you can add two resistors. One is R and one is minus R in parallel to each other. It's not going to affect your Kirchhoff's law calculations. So what I'll do is, I'll just take this red color R, place it here, and a green color minus R in parallel to that. And these two are not going to alter my calculations. So by placing this BC red color resistor, I get back the original grid, right? So can I say the missing resistor grid is equivalent to the original grid and a minus R green color between B and C, which is what I'll represent here. Entire original grid of all resistors can be represented in the format of X, X and X like in the previous slide. Apart from that, the extra resistor now we have is that minus R that would be in parallel to B and C. So let me put that resistor in parallel. Okay, right. So this is my reduction of the circuit. Okay, so already we know the value of X is R by 2. This X is R by 2. And now I have to take the parallel combination of this R by 2 and minus R. How much is R by 2 and minus R in parallel to each other? Simple. R1, R2 by R1 plus R2 cancel calculation will yield this value, which I think you can clearly understand would be equal to how much is this? R itself. Okay, so this is going to be R. So what is the value of RAB then? The value of RAB would be this R by 2 in parallel with this R. Okay, and that, sorry, this R by 2 in series with this R. Okay, and that entire thing is in parallel to this R by 2. Okay, right. So that's it. The R by 2 and R in parallel and in series with R by 2 is what you are going on to get this value as 3R by 8. Okay, right. So again, let me write that for you, the calculation part. The value of RAB comes out to be the value of R and R by 2 in parallel, sorry, in series, R plus R by 2, which is 3R by 2, and that in parallel with R by 2 itself. So 3R by 2 multiplied by R by 2 in parallel with each other, and that makes it 3R by 8. Okay, I think this calculation that I wrote is not correct. It comes out to be the same answer, but it should be R in series with R by 2 and then parallel with R by 2. It comes out to be the same. Actually, if you can exchange series parallel, you'll end up getting the same answer. Okay, so let me move forward now. So this is the practice problem 1 before we move on to the formula sheet for our JEE preparation. So read the question very carefully. It's a basic true or false statement question. So I've given an infinite grid this time. Only difference from the previous grid is now the diagonals are also placed. So these are contacts. So these points are contacts. Here there's no contact. There's no black color. So I marked ABC again, like in the previous problem. Be careful when you are recognizing whether the symmetry is there or not. So I have given 3 statements. For each one, try to state true or false. So if I were to calculate resistance between A and B, it's called RAB. Between A and C, it is RAC. So are they equal to each other or not? Similarly, is RAB equal to RBC in the second question? And RAB is equal to R by 3. Is it a correct answer where R is the resistance of each of these wires? Okay, so comment below along with the timestamp. So when the videos get old, if you don't put the timestamp, it will be difficult for me to answer whether you are correctly responded to the question or not. Okay, so next, before we go on to the practice problem 2 and the formula sheet marked by me, I would request you to go through one of our old videos on the infinite patterns and tessellation techniques. These repetitive patterns are also known as tessellation. And I've done a video in the past which highlights this technique and how JEE can interpret these type of things in their question paper. So link of this particular video is in the description below or in the I button above. Okay, so this is the practice problem too. What I've done is I twisted the IRODOV problem. The IRODOV problem where again infinite grid is there and this thing has already been solved by us in the step one of this particular problem. There it was triangle. This is a square grid. So what we'll twist here is instead of finding the resistance between A and B, let's mark a point between A and B as D, where AD is to DB is 2 is to 1. Okay, and now instead of calculating the resistance between A and B, I would like you to calculate the resistance between A and D point and comment your answer along with the timestamp below. Okay, now to the second most important part of this particular video is the snapshot from the formula sheet by Jaan Kalda sir. Okay, so this was originally the formula list for IPHO, but they contain real good points that can keep your preparation refined for your JEE advanced things. Okay, so you might have written your own formula list, which are quite long and all that, and I recommend writing your own list, but please cross verify it along with this particular PDF file. Okay, so that PDF file contains 4 pages. So before I go on to the PDF file, let me tell you, whenever you see in the marked sheet double ticks means it's compulsory for your JEE Advance. And if I don't mark anything for any of these, that means they are not relevant for your JEE Advance physics examination. Okay. And a single tick, which I put it in blue color, is like it's not um, highly probable to appear in your JEE Advance exam. And also, one more reason why I mark blue ticks is it's very, very common and it's a trivial one. So it could be two reasons why I gave a single tick. Single tick, as you could see, the non-inertial frame accelerations and non-inertial frame velocities, relative velocities, these are very common formulae for us. So this fifth one is very common. It's there for JEE Advanced, but it's so common and trivial that you may skip it, right? And also, there could be situations which are slightly on the border of the out of syllabus or less relevant for JEE. That also I put single, like this ballistic problem or the safety parabola ideas usually are asked in JEE, Olympiads, but may not appear in JEE. But if they appear, you cannot complain. So the single ticks, you can like take it as optional, and which I didn't tick at all, no need to worry about them. But double tick, you are supposed to definitely go through them. And if at all you want to ask me what each double tick problem situations can be, you can actually DM me in my app and I will be able to respond to you. Okay. So how to download it? It's a free resource from our PhysicsSirjee Android app. Just in case you have not yet downloaded, go to Google Play Store, PhysicsSirjee Android app. And once you go into login, and you'll find these 3 lines on the top left corner. You just get a drop down box and there is a study material, or if you're doing it in your laptop, it will be called free study material on the top corner of your screen. Just go into that free study material. You'll find a lot of folders. Just go to the 2023 crash course related folder. In that, apart from the plan for the crash course, you will also have the JE mark Jaan Kalda sheet by Janardhan sir. Okay, that's me. And you just download this and take a printout and try to go through all those ticked things. Okay. So to sum up the video, and just a reminder for those students who have been following me on the app, that there are 4 important things that are right now going on for the JEE Advanced, especially to 2023 batch. Uh, Two of those are the test series. One is chapter wise and another one is the part test and full test. Okay. And the crash course, which is ongoing, is also having 2 batches, batch 2 and batch 1. All the prizes and everything are given in an old video. So the link of that video is in the I button above and the description below. So you can just refer to it. And the difference between batch 2 and batch 1 has also been explained in a previous video. Link of that again in the I button and description below. So if you don't want to waste all your time in watching these videos trying to find out, you just download the PhysicsSirjee Android app. Just DM me about your requirement and join the course and immediately start watching those lectures. All those lectures contain a lot of problem solving methods which will refine your preparation in the last 2 or 3 months and keep you ahead of the competition. Okay, so just pause the video, read through whatever is there, and make sure that you are part of the strong learning group that we have in our app. Okay. So if you want free support also, there is a free PYQs plan that I have put up. So please go through that video. That video's link also is in the I button above. Just go through it, or just stay back in the app, try to DM me about your requirements, and I'll be there to help you as much as possible. So, okay. So I hope you have liked the methodology of the problem solving that we did today. Please try to like, share, and subscribe to the channel so that I keep posting such nice videos that will help your preparation. Okay. So thanks for staying this long, and see you in the next awesome video.